Welcome back to my channel, and in this video we are going to learn about deletion in BST. BST is nothing but binary search tree. Let's see, there are basically three rules to follow, and we'll also see an example problem in the last which would give us a clarity about this. Rule number 1 states that if it is a leaf node, then we need to remove it directly. What is meant by leaf node? See, suppose if we are having 10, 9 and 11. So in this the leaf node is 11 and 9. So if we want to remove any of these numbers, if we want to remove 9, then we'll directly remove this element from here. Then that tree would become 10 and 11. Suppose if we want to remove 11 from here and keep 9 over there, then this would be 10 and 9. Coming to the second rule, if a node has single child, then we just have to replace it with the child. Now, suppose if I am removing 55, then it has only one single child. So what it does is, in place of 55, it would place 65. This rule works when a node has single child. Now coming to the next one, if a node has two children, like if it is not of this case or if it is not leaf node, then that would be the third case. Coming to the third case, now suppose if I want to remove the element 10 from this tree. So what we do is, this is called as the in-order predecessor. The left part of the node which you want to delete. The in-order successor is the right part of the node which you have selected. From the left part, we take the maximum element, and from the right part, we take the minimum element. So, from the left part, the maximum element comes out to be 7. From the right part, the minimum element comes out to be 11. Because at the end, it has to satisfy the binary search tree rules also. So, if we take in order predecessor, then we need to replace 10 with the maximum element of the in order predecessor. So, we write it as 7, 6, 5, and right side we have 15, 11, and 18. The other way of writing this is taking the minimum element from the in order successor. So this would come out to be 11, like we'll replace it with the node we want to delete. So the left part would be the same because we are not changing anything. The right part would get changed. Right side of 11 we have 15, and right side of 15 we are having 18. So this method is in order predecessor method, and this method is in order successor method. Both are correct because when you check the root node now, all the elements smaller than root node comes under left side, which are larger than the root node, they come under right side. The same goes with the next one. So it has satisfied the BST. Now let's look at one example to get more clarity about this deletion in BST. The example states that we should delete the following according to the rules of the BST. So this is the root 25, and we need to delete elements in the same order as he has given in the question. Coming to the first one is 30. 30 is, where do we find 30? So coming to the root node, it is 25. So 30 would be obviously greater than 25. So it would come right side and it would check 36. 30. Now this number is less than the root node, so it would be on the left side of 36. So here we have found this. If we delete 30, see how is it? It has only one single child. So if it has one single child, we need to follow the rule number 2. We'll replace it with the child itself. So this would now become 28, as we have removed the 30. The first one is done. Now similarly, to delete 50, we need to again do the searching. So 50 would be obviously right side of 25 and right side of 36 and also right side of 40, coming to the next root, that is 48. So 50 would be right side of 48. So we have found the element. Now how this is the leaf node. So we can directly delete the leaf node. We are done with 50. Now coming to 8. Where is 8? It would be less than 25, again less than 20, again less than 10, and greater than 5. So we have found it. 8 is also the leaf node. So we can directly delete the element. So we can delete it. Now again coming to 1. 1 would be left side of 20, left side of 10 and left side of 5. It is also the leaf node, so we can directly delete this element. 15. So 15 would be left side of 25, left side of 20 and right side of 10 and right side of 12. This is also the leaf node, so we delete it directly. Coming to the next element, it's 10. Where do we find it? Left side of 25, left side of 20. We have found it. Now it has two children. So this is the case of in order predecessor or in order successor. But since we are having only one element right side, so we take only this element from left side or right side. You can choose any one of the following. So this would become, I want to choose the left side one. So I'll delete this 10 and in place of 10 I'm going to write 5. So this is 5. Now we have completed 10. Now let's go to 40. 40 is right side of 25, right side of 36, and we have found the 40 element. Now let's see how we can use in order successor in this case. Because if only one element is there, we can directly write it. But let's see how do we use the in order successor from this. So now we'll take the minimum element. Minimum element is nothing but it's 45. So we'll replace this 40 with the element 45. Let's see what happens. So we have replaced 40 with 45 and the other two elements are same in their place. Now let's delete 36. 36, again we have to search from root node. So 36 is right side of root node. So we have found it. So again we can use in order predecessor or in order successor. If we choose in order predecessor, then we directly write 28 in place of 36. If you choose in order successor, since it is grouped, like more than one element is present, so we'll take the minimum element from the in order successor. So the minimum element is 38. So you can either replace it with 38 or 28. Now here I want to choose in order predecessor. So I'll replace 36 with 28. See, I have replaced this 36 with 28. Now let's go to the last one, 25, which is the root node. Now if we delete the root node, we can take maximum element from the in-order predecessor. This is the in-order predecessor. Or we can take the minimum element from in-order successor. So the minimum element would be obviously 28. From this, the maximum element would be 22. So in place of 25, you can choose in order predecessor value, that is 22, or in order successor value, that is 28. Let's see how it goes. Here I have chosen in order predecessor, I mean this part. So the maximum element here is 22. So deleting 25, I'll replace it with the maximum element from this. So that's what I have written over here, 22. And all the conditions get satisfied, like these numbers are less than 22 and these numbers are greater than 22. So this is our final BST tree after deleting the following elements. That's it for the video. Hope it was useful. Do like, share and comment your opinions below, and don't forget to subscribe to my channel. Thank you. See you in the next video. Bye bye.